So we're coming up to the end of this unit on quadratic equations, and we got two lessons left, and they're both on applications of quadratics. Okay, and we have done applications of quadratics previously in the last unit, but you'll see how these are different. Hopefully, we're going to try to compare them and understand the difference. We're doing 2 days on this. Today we're doing 3 different questions. 2 of them are sort of similar, and then the third one is a bit different. And then tomorrow we're really doing one more kind of question, a couple examples of it, but at one more basic type. Okay, and those are the types that you'll be responsible for. Um, so let's get started. Okay, remember there's steps involved with these. Sometimes you get overwhelmed looking at applications, but remember the steps. They're going to be similar to the ones in the last unit, so hopefully we're getting used to them and we'll remember them a little bit. But follow those steps. Think about the little tips along the way because they really do help you get started or progress if you're getting stuck. Okay, so the first question, the sum of two numbers is 24. Now, right away, hopefully that's familiar because we did questions like this in the last unit, okay? But there is a big difference between these questions and the ones we did in the last unit. The product of these two numbers is 143. Find the two numbers. So right there, you can see in bold, it's not always going to be that way, but just for this question, it's there. That's the difference. The product is 143. It's telling us what the product actually is. In the previous unit, it says the product, it always said the product is a maximum. And if you remember very quickly, the maximum or minimum of a quadratic happens at the vertex. And in the last unit, that's what we were doing, completing the square to find a vertex. So I hope that you remember that. It's a good thing to go back and review. How to complete the square, and remember that when you complete the square, you're finding the max or the min value. You're finding the vertex, which is the max or the min. So if any question says find the maximum revenue, find the maximum product, find the maximum whatever, it's talking about completing the square. This one is saying it's giving us the actual product. So that's how I know that this question is different, and it's from unit 2 of this course. We're gonna start this question though the same way we started the last one, and that's with let statements. So I'm gonna let, and it's gonna look exactly like the let statements in the last one. Let x represent one of the numbers. Oops. And we're gonna let y represent the other. Okay, the sum of two numbers is 24. That means x plus y equals 24. Okay, so that our first step is our let statements. Our second step is usually a little equation like this. That is not the hard part. That part's done, right? It doesn't involve the product, which is going to be the harder part. I'm going to solve this equation for either x or y. I'm going to solve for y, which means I have to subtract x from both sides. And I end up with y equals 24 minus x. Okay, and that is a key thing that I have to get to for this problem. Next, I'm moving over to the other part, the product of these two numbers. If you remember, product means multiply. So it means x times y equals 143. Okay, but now I have to have an equation that has only one variable. So that's where I take this value of y and sub it in for y. So now I've got x times y, which is actually 24 minus x equals 143. That's why every question gives you 2 pieces of information, that piece and that piece, because one piece is to do this and the other is to do this. And now I have a quadratic equation that I can solve. So I'm going to expand. And I'm going to move everything to one side or the other. I'm going to choose to move everything to the right to get the x term positive. So I end up with 0 equals x squared minus 24x plus 143. And if you remember, it's a lot easier to factor with a positive x squared term, okay? And I always need to set it equal to 0 so that I can solve this by factoring or quadratic formula or whatever I'm going to do. But we always want that x squared term to be positive because that's just how we're familiar with factoring these things. And also, I want it in this form. I want x squared, then x, then constant, because that's just what we're most familiar with. Now, b squared minus 4ac is, let me do this on my calculator quickly, b squared minus 4 times 1 times 143 is 4. b squared is 4. So that's a perfect square because the square root of 4 is 2. So this is factorable. Okay. Now in the next example, I'm going to talk about this a bit further, or the last example actually, I'm going to talk about this a bit further. So I'm just going to go ahead and factor this. I guess I'll mention it now. Uh, if you have a hard time factoring because the numbers are too big, like I said, we're going to see that later, then you can absolutely use the quadratic formula. But this one, I can factor. It's not too bad. X minus 11, x minus 13. Therefore, either x minus 11 is 0 or x minus 13 is 0, which means x equals 11 or x equals 13. Okay. Now, this is really important. This is not the answer. Okay, it looks like it is, and some of you aren't going to be happy about this later on, but this is not the solution. All we found is x. What about y? Because we were supposed to find the two numbers. One of the numbers is x, the other number is y. All I've found is x. I don't have anywhere that says y equals. So I have to go ahead and find y, but watch what's going to happen. If x equals 11, then y equals 24 minus 11, because y is 24 minus x, right? We see that right here. Y is 24 minus x. 24 minus 11 is 13. If x equals 13, because that was my two values of x, what I actually got here was two answers. Okay, then 24 minus 13 equals 11. So that means from this one, I've got 11 and 13. And from this one, I've got 13 and 11. But in reality, these are the same answer. Okay, so I don't need to go through all this. I only need to do it once. I'm going to recognize at this step that this is not the solution, but I'm going to get the same answer to the question twice. So I'm not going to do it twice. So I'm just going to pick whichever one I want, but I would like to see you finding y. So I'd like to see you showing that step, but you don't have to do it twice. And then we're going to write our therefore statement. Therefore, the two numbers are 11 and 13. But again, it's not because of that. Those were two different values of x, because x can be 11, then y is 13, or x can be 13, then y is 11. And both are the same solution. It seems silly, and everybody's going to think, no, that's just the answer. And in this case, it does work out that way, but it won't always work out that way. And like I said, I want to see you finding y after you found x, okay? But you don't have to go through the whole thing of doing it twice and saying the same answer. Just if you notice that they're the same, just do it once, okay? And then state your solution. But it is a bit of a strange thing that happens once in a while. Doesn't always happen. Okay, that was one of the kinds of questions we're going to look at. That was one of those product questions. Again, we saw it before, but the difference here, what you weren't maximizing the product, you were saying the product is a certain value. This is a measurement question, okay? So it involves a triangle, but it's going to end up being a lot like the last one. It's got one little added part to it, I suppose. The base of a triangle is 4 centimeters less than the height of the triangle. The area of the triangle is 13 centimeters. Again, look at it, says is, not maximized or minimized or anything like that, is. Find the dimensions of the triangle accurate to 2 decimal places. Okay, so let statements. Let B, you could use X and Y. I'm going to use B for base and H for height. Let B represent the length of the base. And let H represent the height. Okay. And I'm going to list some of my other information just because it can be easy, it can be useful. Area is 13 centimeters squared. I'm also going to write down, but you don't have to do this. You can just write it down when it's useful. But this is something we're going to need. The formula for area of a triangle, area is 1/2 base times height. We also often call this base times height divided by 2. A lot of people prefer that one. Okay, and in this case, you could use either. In some cases, it's better to have the fraction out front, but in this case, actually, either would be fine. Okay, find the dimensions of the triangle accurate to 2 decimal places. So the first thing we're going to do is our little mini equation, and that comes from this part. The base of a triangle is 4 centimeters less than the height. So the base is 4 centimeters less than the height. So that's the height minus 4. Okay, so I just kind of wrote that out the way that it is by using the logic. This is easier for some people and harder for some people. All I can tell you is think it through, make sure it makes sense of it yourself. The strategy we've used in the past is come up with some examples of using actual numbers. So if the base of a triangle is 4 centimeters less than the height, if my base, I'm going to erase this, but is 10, then my height would have to be 14 because the base is 4 less than the height. If the base is 1, the height is 5. If the base is 15, the height is 19, right? I'm always taking the height and subtracting 4. And after I've written out some of these, that might help me come up with that little equation relating all of the bases and heights. Okay, but some people can kind of just come up with it easily, and some people, they have a harder time making that connection. So using real world numbers or real example numbers can be useful for that. Okay, now I'm going to use my formula for area, and this is why this is different than the last one, because the last one said product. So when I got to this step, I just wrote out the product. It was just x times y, but in this case, it's talking about area. So area is 1/2 base times height. And now I'm going to sub in what I have. I've got 13 for the area. I've got a base of h minus 4 and a height of just h. Okay. The easiest thing to do here when I have a fraction is multiply both sides by 2. And 13 times 2 is 26. And that gets rid of the half. So even if you had used the other equation, base times height divided by 2, you would multiply by 2 to clear that fraction. Okay. So that's the trick for this one. Now I'm going to expand on the right. H times h is h squared minus 4h, and move the 26 over because I have to have this equal to 0. Now b squared minus 4ac is 120. Square root of 120 is approximately 10.95. Not a nice number, not 10, not 11, not a whole number. So this is not factorable, so I have to use a quadratic formula. So therefore h equals negative b. B is negative 4, so 4 plus or minus the square root of 120 over 2 times a, which is 1. So h is 4 minus root 120 over 2, and h is 4 plus root 120 over 2. So h is approximately negative 3.48. I'm just using my calculator for this. And 7.48. Okay. But when I look at these two answers, this is not like the last one. These are not the base and the height, okay, this time. Because this one's negative. And you can't have a negative height. So this is inadmissible. Because it's a negative length. And you can't have a negative length. So always think about the answers, whether or not they make sense. We've talked about this before, which means my height is 7.48 and my base is 7.48 minus 4, which actually works out to positive 3.48. Again, this doesn't always happen, but people think it does. Oh, there was the other answer all along. Turns out in this case that was correct. That was the negative. This is positive, but that doesn't always happen. Okay, it happens sometimes and doesn't happen sometimes. Anyway, but now we're done. We've got the height and the base. It said find the dimensions accurate to 2 decimal places, so I've got that done. So therefore, the base is 3.48, and I think we're working in centimeters here, and the height is 7.48 centimeters. Okay, so we looked at one question that was a product, one question that was an area question, but you can see how it's similar because I still kind of came up with this mini formula and subbed it in, okay? And then expanded, moved everything to one side, and you either solve by quadratic formula or by factoring. So those two are similar. This next one is quite different, and it's not something you've seen before. You don't do these in grade 10, so it's probably very new. Okay. Two negative, and it's very different. You got to see one of these. You're probably not going to be able to figure it out on your own. It's one of the ones where you kind of have to have seen it and practiced a few times to get the idea behind it. Two negative numbers are in the ratio. That's going to be really important later. In the ratio 2 to 5. If their sum is added to their product, the result is 26. Find the numbers. Now, one thing I'll tell you is this question is very different, but every time I ask this question, it'll be basically the same. The numbers will be different, but I'm not going to change it up. So it's always going to kind of give you a ratio, and it's always going to say the sum is added to their product. It could be changed to the sum is subtracted from the product or something like that, but I'm not going to do that. I'm not going to worry about that. We're just always going to make it the same. Okay, so you just do have to practice a little bit on exactly how we answer these kinds of questions. The first trick is I'm not going to let x represent something. I'm actually going to let 2x represent one number. And I'm going to let 5x represent the other number. And hopefully you noticed that the reason I chose 2 and 5 is because of that ratio. So that ratio is going to change every time, but it's always going to be each of these numbers times x as the two things that you're going to let that are going to be in your let statements. Okay, so if it was 3 to 7, it would be let 3x represent and let 7x represent. Okay, so that's always how you're going to do it. Now, what does it mean the sum is added to the product? Well, the sum of two things is 2x plus 5x, because those are the two numbers, and that's their sum. So their sum is added to their product. Well, the product of two things is multiplying them. Okay, so this is the sum, and this is the product. And when the sum is added to the product, it is, so it equals 26. Find the numbers. Okay, so that's the hard part, is getting it all set up and understanding it, remembering how to do the let statements because they're a bit different in this case, remembering how to write this. But once you've got that done, you're expanding, simplifying, moving everything to one side. And that's always going to be how you solve these kinds of questions. I'm also going to put it in the right order. So I'm going to get 2x plus 5x, which is 7x. 2x times 5x, which is 10x squared, equals 26, which means I get 10x squared plus 7x minus 26 equals 0. Okay, and so that's the expanding and simplifying part that I always do, and hopefully that's the easier part, like I said. Okay, once you get your equation written out, that it doesn't matter what kind of a question you're looking at, you're always doing those similar kinds of steps. Okay, once again, I'm going to check the discriminant, b squared minus 4ac. And in this case, it works out to 1089, which I'm looking at it and I'm like, oh, I have no idea if that's a perfect square. But it turns out the square root of 1089 is 33. Again, just checking that on my calculator. Turns out it is a perfect square. So that means this is factorable. But is that too hard? I think so. That's a complex trinomial. It's got a 10 and a 26. Neither of those have too many um, pairs of factors. So you could certainly go for factoring that. You could certainly give it a go. But I'm going to just show an example of using the quadratic formula even for something that's not factorable. Okay. Because when the numbers are big and in applications that definitely happens, you might just choose to use quadratic formula anyway. So negative b, negative 7, plus minus the square root of b squared minus 4ac, we already calculated that, over 2a. So x is negative 7 minus 33 over 20, or x is negative 7 plus 33 over 20. Well, this is negative 40 over 20, which is negative 2. And this is 26 over 20, which is 13 over 10, or 1.3. But that's fine because that's an exact decimal, so I can use it. Otherwise, you would keep that as a fraction probably, okay, until the end when you maybe have to round. If it's an application, we generally will round in the end, but for now, it's a good idea to keep it as a fraction, have the exact. So now I've solved this equation and I found my values of x. I'm going to go back up and I'm going to remind myself exactly what I'm doing here. And this is where I got to reread the question. Two negative numbers. So often we're in the habit that we get two answers. One of them is negative and I discount it. I get rid of that one because it's negative. But in this case, it says the answer is two negative numbers. So that means this is actually the one that I want, and this one's inadmissible because it's supposed to be negative. Okay, so this is a great lesson because it's not always the negative answer that you're tossing out. Sometimes it's going to be the positive answer that you toss out. You got to think about the actual question. Now, this is not my answer. This is x. I'm supposed to find the numbers. Remember, the numbers are 2x and 5x. So now that I have x, what I want to do is find 2x and 5x. Okay, so I've got x equals negative 2. That means 2x is 2 times negative 2, which is negative 4. And 5x is 5 times negative 2, which is negative 10. So these are my two numbers. Before I move on though, I'm going to try to check this and just make some sense of it. You don't have to do this. It's not a bad idea, always, especially if you have time. Okay. And remember it says there are two negative numbers. Well, I got two negative numbers, negative 4 and negative 10. And it says their sum is added to their product. So what's the sum of the two numbers? Negative 4 plus negative 10. plus their product, negative 4 times negative 10. Negative 4 plus negative 10 is negative 14. Negative 4 times 10 is 40. Negative 14 plus 40, or 40 minus 14, is 26, which is what it told us in the question. The sum is added to the product, the result is 26. So that means that is what I was supposed to get, so I did it right. So therefore, the two numbers are negative 4 and negative 10. Okay, and that seems strange the first time you see it, but you practice it a few times and it's not that bad. It's basically the same every time. Your let statements are a bit strange. Coming up with that equation of the sum added to the product is a little bit strange, but if you do it a few times, hopefully you'll get it. And this is a good example of using quadratic formula. Even when something's factorable, it's all about doing what's fastest, most efficient. Factoring is great unless it's really hard factoring, then it might not be worthwhile. Okay, so that was day one of applications of quadratic equations. We did three sort of different ones. The first two were similar. The third one was different, but three different examples. Like I said, tomorrow we're going to look at another example, two examples, but it's the same idea, and it's one that you've seen in grade 10. We'll look at that a couple times, and that will be that. And those are sort of the types of questions that you will be responsible for in this unit for this course. Okay, good luck.